Good afternoon, everyone, and welcome back to theCUBE's live coverage of Vast Forward here in Salt Lake City, Utah. I'm your host, Rebecca Knight, alongside Dave Vellante, my co-host and analyst at theCUBE. I'd like to welcome Jonsi Stefansson. He is the GM of Cloud at Vast. Welcome, Jonsi.
Thank you, Rebecca, and Dan, awesome to be at theCUBE.
Direct from Reykjavik.
Direct from Reykjavik, Iceland.
We're going to be talking a little bit more about Polaris later in the conversation, but I want you to begin by setting the context for our viewers in terms of where you sit and AI forcing this rethink of cloud architecture. And from your vantage point, what assumptions about traditional cloud architecture are breaking down right now?
I think, AI isn't running in a single location anymore, or it actually never has. I mean, AI is running at the far edge with autonomous vehicles, sensors, drones. I mean, there's a lot of data being generated all over the place. And the traditional setup today is that our customers are running on-prem, their enterprise applications might be running on-prem. Their training and fine-tuning environments or framework might be running in the neoclouds. And their inferencing and RAG pipeline might be running in the cloud. This is a very complex environment, especially when you want to manage your AI pipeline. And I think it sort of takes this, I hate to say it, bullshit of lift and shift from legacy providers. It takes it out of the picture. Nobody's lifting and shifting petabytes and exabytes of data into multiple different locations. And I can give you a great example. We had one customer that was a design partner for us working with Polaris and Vast on cloud, or the Vast AI operating system on-prem and in cloud. That customer had around 17 different copies of the same data sets running in different regions, different on-prem, in different neoclouds. 17 copies. That shows you how the lack of overview is in today's world. After they adopted Vast AI operating system, they went down to 3 copies. But we want to get them down to a single copy. Well, I'll correct myself. Let's get them to 2 copies. We can't disregard backing up your data.
Right,
so let's say 2 copies. That would be an amazing, and that customer went from roughly 480 petabytes down to 50. This is what the modern cloud, the AI infrastructure and the AI pipeline needs to get to. You need to be able to take advantage of global namespace.
So
Dave is going to really geek out.
First of all, lift and shift, totally agree with you. It was always a Trojan horse.
Yes.
My business friend, Alan Nance, rest his soul, when he was the CIO of Philips Global Infrastructure, he said, lift and shift, not going to get you much.
Yeah.
Unless you change the operating model, cloud, don't even bother.
Absolutely.
And he was right. He said, we can put billions to our bottom line, but lift and shift won't do much for you. So I totally agree there. In 2021, we coined this term super cloud, because we observed that there was something more than multi-cloud. Multi-cloud was basically, I run on this cloud, and I run on that cloud, and I run on this cloud, and it's all different. Super cloud was this abstraction layer that hid all the underlying complexities of the individual cloud, or even on-prem, and the developer saw the same policies and edicts and same experience across, irrespective of physical location. So that's what Polaris is, correct?
Yes.
I call it a super cloud. You don't use that term. It's tongue-in-cheek.
No,
we got a lot of crap for that term, but
I kind of love that term, though.
But it's what it was. It's an abstraction layer in a single global namespace.
Yeah.
So explain that. You got to back it up. 2 copies. I'd say maybe even 3, so you can physically, have asynchronous. I don't know.
Yeah.
In cases of a flood or a fire or an earthquake. But okay. But make as many copies as you need, but no more.
Yeah.
As Einstein would say. So explain Polaris.
Yep.
And what actually the architecture, technically looks like.
So when we joined Vast, we started designing designing Polaris to solve a relatively simple problem. Basically just get VAST running through the marketplaces, be a licensing server, be like, have all the entitlements, automate the deployment and the full lifecycle management. You know, expand clusters, and just like the typical cloud control plane.
Go to market kind of thing.
Yeah. But I mean, technology, of course, we were making it very, very simple to deploy and manage and operate vast AI operating system in the cloud. So we started off with deploying within the customer tenant. It's still fully managed. So we did what we have the Polaris agent that actually communicates to, that resides on every single VAST node. So it was a relatively simple problem for us to solve. I mean, every company in the world has a service delivery platform. Anybody that are in the cloud, they have a service delivery platform. But here's the beauty of working with VAST. And I'm telling you, I haven't had this much fun in years. I feel like I'm back in startup world. The startup mentality is so rich, and the founders of the company, they are always challenging you to go further and further and further. So we were actually taking advantage of a lot of native services within each one of the clouds. Like we were running on their Postgres as a service, or we were running on their Redis. But ultimately, Renan, Jeff, Alon, and Shakar, they were like, hey, this is really cool. You're making it really simple to manage VAST. I want you to go way further. I don't want you to be using any of the native services in the cloud. I want it to be completely self-contained. And basically, I'm abstracting the infrastructure away from the control. So Polaris is now is taking on the data engine orchestration, is taking on the data space orchestration. Like for example, if I have multiple clusters, and we demoed that for a bank with the fraud detection, that we actually allowed them to deploy Polaris within their on-premise environment. You can actually run Polaris now on your laptop and manage a fleet of Polaris deployments all over the globe. So we have completely abstracted that, and we're taking more and more sort of logic and intelligence into Polaris. And that's why it's been so much fun, because you're no longer just doing the cloud control plane part and the marketplace integration and the deployment. You're actually taking care of the intelligence as well, and the placement policy algorithm and the policy engine that probably Jeff talked about. Yeah, how are you deciding intelligently or autonomously or allowing agents to decide what data set gets accessed from where, how the locking is going to be done? So those logic are actually finding its way into Polaris. So Polaris is becoming that intelligent layer or centralized intelligent layer for distributed execution.
And you do that not by, or maybe you are, you're not putting the vast code in all the different clouds. You have a single single point of control, is that correct?
Yes, I am communicating to the management plane of vast AI operating system, which is called VMS. I am communicating with them on an API level. So I am deploying. But what we are also doing, and maybe I'm telling a little bit too much, but we are also deploying a vast Kubernetes operator that can basically sort of mimic or take specific capabilities of VAST and have that deployed at the edge, or even at the far edge, at the devices that we want, in order to be able to manage what data gets pulled into the core or into the cloud.
So if something goes wrong, who's in control? How does that work? How does that recovery work?
So there is a reverse tunnel that you don't have to, it's basically using gRPC. So there is no security ports that you have to expose or anything, but Polaris is in control. But there is also a lot of logic in the VMS that is managing the vast AI operating system or the vast cluster. So there is automatic reactions and remedies that VMS can do even if you have no connections to Polaris. That is the brain. We are the distribution and the fleet management and the intelligence to control what data goes where. So we are an abstraction layer and very complementary to VMS. So that's how I would describe it. It's in that intelligent layer.
Yeah. Very clever.
Can we bring this conversation down just a little bit and just you started by talking about this example of allowing a company to go from 17 to 2 or to 3.
Yeah.
What other kinds of capabilities will this unlock for enterprises?
I think it's going to be very easy for them because, I mean, let's be honest, there is certain level of supply chain crisis in the world today.
Oh, and yes.
Absolutely. And you have to have the flexibility to actually figure out where do I have compute availability? Where do I have GPUs availability? Where does my data reside? And we want to solve exactly that. We want to be able, and we've actually built into Polaris a polling agent that is actually constantly checking the price of GPUs across neo clouds, public clouds, where you have your vast clusters residing. It's basically polling, and it actually pops up and says, hey, you have GPU availability, and you can define that search. Let's say you need 1,000 GPUs. It's going to be difficult for you to find it. Yeah. But all of a sudden, 1,000 GPU availability popped up in Singapore. I'm going to deploy VAST and Polaris in Singapore, connect the clusters together, create a global namespace, and start taking the appropriate, and basically using caching the right data sets for that workload, the GPU or AI workload or that training framework to take advantage of. And I'm not keeping the data there. Like, it's temporary. And then I'm just pulling it back or cutting the mirror, and I'm going off to the next place.
Okay, so you're
and I can even do that going to like CoreWeave.
So, so you're actually not bringing the compute to the data, you're bringing a subset of the data to the compute.
Yes.
And then you synchronize it across the network.
Yeah.
How and when, and like asynchronously or
well, I mean,
eventually?
I mean, you can choose to do async. You can choose the replication method or caching method, how you want to do it. You can take advantage of the snapshot clones and move a portion of a data set. Yep. So you can, but I mean, ultimately, there is something that you have to take into account, and that's the egress and ingress charges of the public clouds. I mean, they're not going to charge you for bringing data in, but they're damn sure going to charge you for bringing data out. So
great business model.
Yeah, but doing that way with the global namespace and caching only a subset of your data that is needed at any given time is a massive game changer. You're not waiting 3 days to get that data set. Yep. I mean, it takes time. We are not breaching the laws of physics. We're just making it more efficient. So
the increased flexibility, efficiency, the cost savings, and organizations, enterprises all recognize they want and need these things, and yet you started this conversation by talking about, and we're a family program, but the mores of lift and shift and how AI is not lift and shift. So our customers, the conversations that you're having, is this something that they already recognize, or is it also persuading them of something, or telling them that something is possible that they don't quite believe yet?
I think this is a great point, and I think the only way to actually get them to believe you is, and this is where VAST truly excels, allowing them to just test it. Have a POC, and now that we are in the cloud, you can get a POC up and running in a matter of minutes. And then they can start testing the global namespace. But it's not only the global namespace and the data spaces that is the unique value proposition of VAST that is totally different. It is also the data engine. I think that actually brings almost the same amount of efficiencies and cost savings. Because imagine that you can consolidate your entire AI pipeline into a single platform. You can, within VAST, because of all our features and capabilities, because it's no longer a storage system, of course, storage is the key, but ultimately, it is that AI operating system capabilities of unifying or consolidating your entire AI pipeline into a single platform that is right next to the storage. You basically can have the data engine or the database. You can basically start contextualizing all your unstructured data within the same platform without having to migrate it. And even in the cloud, if I'm running in a cloud service, I have to copy it from an S3 bucket, or I have to copy it from a file or a block level. copy it so Vertex AI can actually understand it. Then I've already duplicated the data. In VAST, it's all happening at the same time. And imagine having a multi-protocol that is not only the storage protocols, but it's a tabular as well. So it's the Vertex AI, it's the Kafka broker. No, it's not the Vertex AI, it's the vector DB. So you can actually vectorize your unstructured data on the fly without migrating it. So you're basically like, there's so many efficiencies that people need to start evaluating, because SSDs, one of the scarcest resource in the world. DRAM, well, can't even get that. People are basically taking over their PC and trying to get some SSDs.
But what I'm hearing is part of the secret sauce is you persist the context, right? And you can bring that to wherever it needs to be.
Yes. I think that's the biggest value proposition that VAST brings to. And maybe some people say, hey, VAST is late to the cloud. No, this is the perfect storm for VAST to be everywhere because of the efficiencies that we are bringing to the table. The supply chain issue might be a challenge for the legacy providers. Is actually a massive opportunity for us, because we want to be everywhere, and we can actually go into an event, and we are doing this so much today on-prem, that we are displacing other technologies, and we're displacing our competitors, and prolonging the life of the existing hardware. The same thing goes in the cloud. And in the cloud, we are one of the few that actually are passing our data reduction to the customer. Most of our competitors, they are actually keeping that efficiencies in order to increase their margins.
Sure.
We are giving it away. So the average data reduction ratio that we are seeing in the cloud today with the customers that we have there is roughly around 1.8 to 1. So you're basically getting almost twice the amount of storage
for no
than
extra
you're
cost.
paying for no extra cost. So
nice.
Incredible, a great note to end on. Jonsi, thank you so much for
thank you so much.
Thanks,
coming
appreciate
on
the
show.
conversation.
See, I'm very passionate about this. So
You're having more fun than you've had in years. So
That's
and
true.
It shows.
That's
it shows.
true.
Well, thank
That's
you
true.
so much. I'm Rebecca Knight for Dave Vellante. Stay tuned for more of theCUBE's live coverage of VAST Forward 2026, presented by Solidigm. You're watching theCUBE, the leader in enterprise tech news and analysis.